Okay, here's another example of solving an exponential equation. So this is the second part to example 3. And you'll notice again on the left-hand side we have two terms that are exponential, and on the right-hand side we have a single term. And so again we can't find the logarithm of both sides, and that's because we have more than one exponential term on one side of the equation. Now you might be thinking, what if I just take one of the exponential terms and put it on the other side? You still can't do that because you have two terms, one of which is exponential, and you can't find the logarithm of multiple terms where one of them might be an exponential function or an exponential term. So the previous example we looked at, we were able to split up one of the exponential terms into two smaller parts. And so if I look at this one, if I want to rewrite 3 to the exponent 2x in a different form, now I know that this is not going to be equal to 3 to the exponent 2 times 3 to the exponent x. And I know that these are not equal to each other, and that's because 3 to the exponent 2 times 3 to the exponent x is actually 3 to the exponent 2 plus x. Now, that's not the same as what I had started with, so I know that's not correct. So that doesn't work. Okay, so unfortunately I can't solve this problem like I did the last one. Okay, in the last one I had x plus 2, and this one I have 2 times x. But what I could do is rewrite this as 3 to the exponent x to the exponent 2. Okay, and so if I use the power of a power rule, 3 to the exponent x multiplied by an exponent of 2 gives me an exponent of 2x. So these two mean the exact same thing. And so maybe I can consider writing this as 3 to the exponent x squared. Okay, so let's try writing that down here. So this is like 3 to the exponent x squared minus 3 to the exponent x equals 12. Now you'll notice that on the left-hand side, the exponential part looks exactly the same. The first one has an exponent of 2 applied to it, which is not that big a deal, but the second one is just 3 to the exponent x. Now, this is actually a quadratic form of an exponential equation. Now you might be wondering what I mean. Well, let's try to solve this using a quadratic equation instead. I have a squared term, a not squared term, and then I have a constant term at the end here. So what I could do is replace the exponential part here with a different variable and solve the equation like a quadratic equation instead. So for example, let's say I let y or u, whatever variable you want to use, I'm going to use u. So let u equal 3 to the exponent x. And so what will end up happening is I can rewrite this equation as u squared minus u equals 12. Now that looks like a quadratic equation, and I know how to solve this quadratic equation. So what we're going to do is we're going to solve this quadratic equation like you normally would, and then try to solve the exponential function from there. Okay? So rearrange it so I get u squared minus u minus 12 equals 0. And so I'm going to try to factor this. If it's not factorable, I'll use the quadratic formula. In this case, luckily, it is factorable. And so I have a product of negative 12 and a sum of negative 1. So I know the two factors would be negative 4 and 3. So I get u minus 4 times u plus 3 equals 0, which means u equals 4 or u equals negative 3. So there's my two solutions that I get from the quadratic equation. Now remember that u is equal to 3x. So what I'm going to do now is to actually solve for the variable x, which is what I'm looking for in the first place. I'm going to rewrite both of these with an exponential form instead. Okay? So I'm going to replace u with 3x. And I'm going to replace the other u with 3 to the exponent x as well. Okay? So what you'll notice is the left-hand side, or the first solution, where it's 3 to the exponent x equals 4, this is actually something I can solve using logarithms. Whereas the second solution that I have, which is 3 to the exponent x equals negative 3, is not something I can solve because a power should always give you a positive result. And because this is not a positive result, I know that this is an extraneous root. So I don't have to do very much with the second solution. This one gives me an extraneous root, so it's not valid. Okay, so I can ignore this solution. Okay, whereas this one I'm going to use logarithms to help me solve. And so I get x times the log of 3 equals the log of 4. And so x is equal to the log of 4 divided by the log of 3. And there's the exact solution that I needed to solve the equation. Okay? If I wanted the approximate answer, I can find it on the calculator by finding the log of 4. And then dividing it by the log of 3. And I get about 1.26 for the value of x. So there's my solution. There's only one answer that will make the statement true. So even though we started off with a exponential function that we rewrote as a quadratic function, we were still able to solve for it and get two solutions, one of which is extraneous and the other solution is valid. So the only value of x that makes this statement true is log of 4 divided by the log of 3, or in other words, value of x that's approximately 1.26. Okay, so there's an example with an extraneous root. Just to recap what we did here, I rewrote this as 3 to the exponent of x squared, which means the same thing as the previous step. And what you'll notice is I have a quadratic term since I have an exponent of 2. I have a linear term since I have an imaginary exponent of 1. And then I have a constant term, which is just a number that I had at the end. And so I can replace the exponential term with a variable like u. Okay, obviously I want to use a variable that's different than the one that I originally have. And then if I rewrite it, I can see a quadratic equation, and I know how to solve a quadratic equation. So in this case, the equation was factorable. Sometimes at this step, you might need to use the quadratic formula, but in this case, it was factorable, so we were able to solve it without using the quadratic formula. But situations like that can come up.